Hi, my name is Patel. In the last lesson, we learned what a right rectangular prism is. We looked at some real objects which are right rectangular prisms. In this lesson, we're going to look at these same objects in 2 dimensions, the way they're represented on paper. That is, in diagrams. So, by the end of this lesson, you should be able to identify right rectangular prisms from different positions, represented in 2 dimensions, and use dotted lines to show the hidden parts of prisms. I suggest that you have a matchbox with you to try some of the activities. First, we need to look at 3 planes or positions in 3-dimensional space. Do you remember what the difference between a 2-dimensional and a 3-dimensional representation of something is? If we say something has 2 dimensions, what are those 2 dimensions? Length and breadth. For example, this rectangle has length and breadth. So, if something has 3 dimensions, what is the 3rd dimension? Height. So, this block is 3-dimensional because it has height as well as length and breadth. Any object that takes up space is a 3-dimensional object. We say that it has position in 3-dimensional space. And 3-dimensional space is made up of 3 planes. To make this easier to understand, let's look at this paper model of the 3 planes. The first plane is called the horizontal plane. Think of it, say, as the surface of the table. It is this part in our model. The second plane is perpendicular to the first plane. It is called the vertical plane. The last plane is perpendicular to both of these planes. On the model, it is this part. If you change the position of your eye, you can see the different planes from different views. Can you see that the position of my eye moves as I move? Let's have another look at these planes, but this time as shown in drawings. Watch how you can see different planes as they move in space. First, the horizontal plane. If you change the position of the eye, you get a better understanding of how they fit together. Then, the vertical plane. Once again, changing the position of your eye helps you get a better understanding of how the planes fit together. And here's the last one, the plane which is perpendicular to both of the other planes. Keep in mind how these planes fit together and how they look in diagrams. This will help us to see how we represent objects on paper. Okay, now let's go back to our right rectangular prism. Look at this drawing. It is flat on the smartboard, but your eye tells you that it has 3 dimensions. People have learned how to represent objects in the world on paper to look as if they are in 3 dimensions. Where would you say we're looking at this object from? Above it? Below it maybe? Above and slightly to the left or to the right perhaps? directly from the side. In fact, the way this prism is being shown here is to the left of the viewer and below the eye level. How can I tell? Well, if I move the object to the level of my eye, I can only see one face. If I proceed to move it to the left of my eye, I can see another face. If I then drop it below the level of my eye, I can see a third face, which is similar to our diagram. Can you see how the view of the object changes when you change the position of your eye? Now, take your matchbox and hold it somewhere so that it looks like this diagram. The face PQUT is in the same position as the vertical plane we saw on the computer. It is also called the front plane. The two other faces are not in the vertical or front plane. Can you see that these three faces are in the different planes that we showed earlier? Here is the horizontal plane. Here is the vertical or front plane. And here is the third plane perpendicular to the other two. If I take this apart, you can see that the faces do not look like rectangles when they are separate. But our eyes read this as a rectangular prism. Here's another useful tool for understanding drawings of three-dimensional objects. When we draw, we make use of conventions or rules of drawing. In this way, anyone in the world can understand what is meant by a drawing when they see it, without having to be told what is meant. In this drawing, you will notice that some lines are solid and some lines are dotted. These dotted lines are used to indicate those parts of the figure that are lying in the plane or space that are hidden from our eyes. Compare this right rectangular prism with this model. The three rear edges of the model cannot be seen by the eye. This is shown by the dotted lines in the diagram. Now look at these three diagrams. They represent three-dimensional objects, but they do not have any dotted lines. For each of these diagrams, where will you put in the dotted lines? Depending on how you look at this diagram, you could make these lines dotted to show that this is the back corner of the shape. And if you see this cube with this corner at the back, then it needs dotted lines here. If we see this as the back corner of this triangular prism, then this is where we need the dotted lines. We have covered some useful conventions and ways to understand diagrams of three-dimensional objects. So let's recap what we did in this lesson. In this lesson, we first looked at the three planes that we work with. Then we looked at objects from different positions of the eye. We also looked at how to show the hidden lines in three-dimensional objects. We used dotted lines. Here's something else to try. Take your matchbox and turn it lengthwise like this. Put it to the right of your eye and a little bit below the eye. Can you make a drawing of this viewpoint of the matchbox? I hope you enjoyed learning these new skills. Until next time, salang sint.